Oreper from Bitmovin. He's going to talk on AV1 in the real world.
The real world. Does everyone remember that show? Yeah, this is a whole different real world. It's the real world of compression. So my name is Igor. How's my mic? Okay. Okay. A little scratching. Yeah, maybe I'll move it down. Is that better? A little better? Okay. So I am from Philly. I work for a little company called Bitmovin. We are about 170 employees based in Austria. We've got an office in Denver. We have folks kind of all over the world. And we make tools for video developers to build really great video streaming services. That's what we do. And we don't make all the tools. We just make a few of them, an encoder, a player, and analytics product. So some of you may be familiar. In making those tools, we tend to adopt new technology. We don't adopt all new technology, but we do stuff that we think is going to be useful for video developers in the future to build great video streaming services. And so about 5 years ago, we got involved in AV1. And before it was AV1, there was the Alliance for Open Media. And I'll go through a little bit of history, but in a nutshell, a bunch of companies got together and said, hey, we need, we need, I can't move this way or this way. Okay, I'll stay right here. So we need codecs, right? And only one slide. Did that work? That worked. We need codecs. Why do we need codecs? Because video makes up 80% of the content transferred over the internet, which is crazy. And that's been the case for a few years. It's kind of holding steady there at 80%. Do I need to change anything? Stay perfectly still. Okay. All right. Does that work? Does that work? Okay. Less scratchy. Great. So video, 80% of the data transferred over the internet, and networks are super expensive. Has anyone ever worked in a company that runs a network? Yeah, super expensive. And so we turn to compression to make our content smaller. And if 80% of your content's video, compression for video is really, really important. And so codecs, right? That's why we have video codecs. And so just a little bit of history. Back in 1999, we had the MPEG-4 codec. AVC comes out in 2003. Not a lot of codec innovation, I would say, pre-AVC. Meanwhile, Google is working on, let's fast forward a little bit more. We have VP8 and VP9, right? Google primarily is working on those two codecs. They started working on VP10. Cisco was working on Thor. Mozilla was working on Dala. And so all these companies kind of came together and said, hey, really makes sense to form an alliance for codec development, which is royalty-free, right? Because codecs, for a long time, they come with royalties. Royalties are kind of confusing. Nobody's really sure who's supposed to pay for what and how much. And there's patent pools and folks who maybe have rights to, who haven't even joined those patent pools, right? So there's a lot of risk, especially if you're a device manufacturer or a content provider. There's a lot of risk in choosing a codec that you may end up, that may end up being a liability for your business. And so Amazon, Cisco, Google, Intel, Microsoft, Mozilla, Netflix, all kind of came together to form the Alliance for Open Media. And they decided to collaborate on a new codec called AV1. So VP10, Thor, Dala, all those were sort of, I would say, became the what is now AV1. And so in 2018, AV1, sort of the beta release for AV1 was launched. And everyone was like, great, we have this awesome new codec. It is incredibly efficient once you get the output, and it is incredibly expensive to generate that output. So not very practical for those reasons. Also, not really practical because the ecosystem's not ready. There are no devices that can decode content that's encoded with AV1. It doesn't work at that time for all types of content, right? MOD, live, RTC content. It doesn't work for, you can't get all the innovative quality features with HD, HDR, 8K. And then came along Netflix, YouTube, Facebook, and they started to create content and experiment with AV1. And so that started back in 2018. In 2020, Netflix actually deployed AV1 in the wild for the first time for Android devices. And the result of that experiment was a 20% savings in gigabytes delivered, right? So really big. I mean, when you look at 80% of the content over the internet is video, guess who was the #1 distributor of that content? Still is. Who? Netflix. Netflix #1. Who's #2? YouTube. So, we'll get, the top 10 list is interesting, but Netflix and YouTube, Netflix and YouTube were kind of the big two, still are. And so they began to experiment. And so I want to talk a little about adoption of AV1 over the last 4 years. This is a chart that comes from the Video Developer Report, which is something that Bitmovin, it's a survey that Bitmovin does to hundreds of video developers out there. We've been doing this for a number of years. And so you can look at, this is specifically for AV1 adoption over the last 4 years. And you can see in 2022, we just published this report back in September timeframe. So, it's starting to grow, right? 15% are already deploying AV1 out in the wild. And so when you look at, okay, well, next to AV1, what other codecs are you using in the real world? That's a funny looking chart on a black background. But you can see AVC is still big, right? But it's decreasing. Why? Because AVC is, works everywhere. Not super efficient, but it works everywhere. But you do have this uptake of HEVC, MPEG-2, right? Still MPEG-2 is out there, VP9, VP8, and AV1. And AV1 is definitely coming up in popularity. And then we asked the question, well, which codecs are you going to implement in the next year? And when you look at what codecs are you going to implement, HEVC and AV1 are in the top 2 positions. So definitely a lot of interest in those two. And of course also VVC, which is the next iteration of HEVC, or H.266. So let's talk about some of the big services that have adopted or are adopting AV1. YouTube, they started in 2018. They have official support for Android TV devices in 2020, and they started encoding their most popular 4K content exclusively in AV1 starting September of 2021. Right, so most popular videos, it made sense to compress those because those are the ones that they deliver over and over and over again. So that's what costs the most money. Facebook initially did their comparison against AVC and VP9 back in 2018. The findings were basically what they are today. Compression compared to AVC was 50% better with AV1. Compared to VP9, it was 30% better. Those are still the numbers that we see. But what was interesting, and this BD rate chart that you see in the bottom left hand corner, the compression was there, but it took so much more compute to create those encodes. Again, was not practical to do at scale in 2018. The other interesting finding is, it actually improves the user experience, right? So not only is it cheaper to deliver over the network and you're conserving some space, so it's efficient, but also users are getting a better experience, right? Viewers are getting less buffering as a result, and they reported 30 to 50% less buffering for the assets that they encoded in AV1. They started rolling out in 2019, and Mark Zuckerberg posted an Instagram reel just last November comparing AVC to AV1, and I don't know if you can see, I don't know if you've seen that Instagram reel. Check it out. It's a pretty huge difference, right? For Instagram, I think it's 157 kilobit, right, small stream, but the resolution on the right-hand side for AV1 is far superior. And so now this is rolled out in production for content both on Instagram and Facebook Reels. Netflix began streaming to Android devices in 2020, and they've expanded to 4K TVs in 2021. Again, they reported higher quality across sessions, fewer quality drops, better startup times, and more streaming in 4K resolutions, right? So more the devices and even in sort of bandwidth-starved networks are still capable of streaming really high-quality content at very, very low bit rates. So adoption's happening at that scale, and everyone else is saying, well, okay, at that scale it makes sense. They're delivering some of their popular assets millions of times, and so I'll get to kind of the cost implications. But let's talk about devices. Devices haven't really supported, they were not able to decode AV1 for many years, and so now that's changing. Android now is able to decode AV1. You can look at their specs. The Android open source media project, there's a commit just recently that references a standard for Android 14 that says it must support AV1. So we know it's coming for Android. Samsung TVs, and really all the TV manufacturers are jumping on board. Samsung now supports AV1 streaming. LG, their AV format on WebOS 5 supports AV1 streaming. Fire TV Stick supports AV1 streaming. So little by little, all the device manufacturers are starting to add support for AV1, either software or hardware decode, where possible. Even Roku Streaming Stick. So this is an interesting one. This is a Stats for Nerds overlay for an AV1 asset that we plugged into a Roku streaming stick over a USB dongle. And so it's able to decode AV1 using a Realtek chipset. So the hardware adoption and capabilities are now there. We think that Roku is going to be releasing these in the wild as well, very soon, hopefully. That was back in July. And then browser support. I mean, when you look at browser support, basically all browsers at this point are supporting AV1 except Safari and Opera Mobile. Those are the only two. And then for some, like Edge and Firefox on mobile, you have to do some, it's not enabled by default. So you have to change some settings to get it enabled. But the browsers are now supporting AV1 as well. Apple. Everyone's probably wondering, well, where's Apple in all of this? So Apple introduced, I think this was pretty recent, but their AV Foundation, which is the client playback framework for Apple devices, they introduced a new video codec constant AV1. So AV1 is coming to Apple as well. Question is when. Nobody really knows. The latest M2 chipset that Mike has in his laptop doesn't support hardware decoding, but we think that the new A14-based chipset will. And maybe that's next year, maybe it's the year after. Not really sure, but the same thing happened with HEVC. Apple only added HEVC support back in 2017, right after it's been available for a few years. So a little late to the party, but definitely I think that's coming as well. So in summary, most devices support AV1 decode today, either hardware or software. And when you look at kind of the universe of devices, and we look at this from the perspective of Bitmovin Analytics, we look at what codecs are supported for each play that our customers are using our player for. So we do about 1.7 billion impressions every month. And of those, we estimate about 40% of those impressions are AV1 compatible, which is a pretty high number, right? And of course, that's spread across the world. It's higher in some regions, it's lower in other regions, but about 40% of devices that are actually playing video today are capable of playing back AV1. And that's pretty exciting. So I'll tell you a little story. Back when I started Bitmovin about 5 years ago, at the time I actually started, my first day was at NAB in 2018. It was a weird first day to start at a company. But we were doing an AV1 demo, and at the time it was really just, it's a cool factor, it was an interesting concept. The compute needed to create an AV1 asset was about 200 times more than you would need to create an AVC asset. And so, of course, possible, right? We have lots of cloud compute infrastructure from all the public cloud providers, but totally impractical, because that's really, really expensive. Today, it's 10x. So now it's, and I'll talk about the costs towards the end of my talk here, but it's actually possible to create AV1 content and to distribute it at scale without spending money. In fact, you can save quite a bit of money at this point. More details on AV1 support. This is an eye chart. I recommend check out bitmovin.com. We have an AV1 microsite that you can look at this table. You can look at all these other metrics as well. But the AV1 support is really broad across the devices. So now let's look at some charts. Does anyone know who this is? Okay. So I googled how to pronounce his name, and I'll still mess it up. But it's no, I already forgot how to pronounce the first name. Let's just call him Giselle. Let's call him Giselle Giselle Bjontegard. Norwegian. He was instrumental in developing AVC, MPEG 2, MPEG 4 codecs, right back in the 80s and 90s. And so he also developed the idea of the BD rate chart, right? So for folks who may not be familiar, pretty simple chart, right? This is what it looks like: quality good, cost bad. So you want to kind of be up to the left over there, right? And that's the whole premise for these either BD rate charts or VMAP charts. You want your ABR renditions to be as far to the top left as possible, right? That means higher quality, lower cost. And so we did some VMAP comparisons of AV1 compared to VP9, HEVC, and AVC. And so this is the result for one of those. The blue line that you see there, right, to the up and to the left, that's an AV1 ABR set. And for the same asset, you're talking about 50% reduction compared to AVC. You're talking about a 30% reduction compared to both HEVC and VP9. So that's the compression improvements. More VMAF charts. If you love VMAF charts, go to our website. You'll see plenty of VMAF charts, but they all look similar to this. And so that's the value, right? You can improve the perceived quality. You reduce the startup time for users. You reduce the buffering for your users, and you can use the same codec for all these different content types. So that's ultimately the value and the benefit. Now, what happens when you look at the cost-benefit comparison, AV1 to H.264 and AVC? Okay, so it costs more compared to AVC, 10x more to encode it, compared to HEVC, 5x more to encode it. But you're only encoding that asset once, right? What you're saving, the 50% or those 30% that you're saving on the file size, if you're doing that for popular assets, you're saving that again and again and again. Every time a viewer is watching this content over the internet, you're saving money. And as a bonus, you get some VMAF points, some gain in perceived quality, which isn't bad. Nobody really turns that down. So how practical is it? You can play around with this calculator. We published the calculator to our website on bitmovin.com. And when you plug some numbers into that calculator and you do some math, this is kind of where you end up. So we modeled this after one of our customers, a large SVOD service, OTT streaming service in the US. So if you assume 40% of your devices are supporting AV1, you're saving about 60% on egress from origin, on CDN delivery fees. Sure, you're paying more for storing an extra codec, right? You can't get rid of AVC yet, so you can't get rid of HEVC yet. You have to add AV1 as a new codec. So you're paying extra for storage. It's not a huge cost because you only have so many assets you're probably going to do this for today. And of course, you have to pay an increased cost to encode those AV1 assets, but you're only doing that once. And so the bottom line, when you plug the numbers into the calculator, is any asset that's going to get viewed more than about 10,000 times, it's worth it, because you're going to save money downstream of the encoder. And so check out the calculator. I think it's pretty cool. You can plug in your own numbers, and that may change the output, right? Maybe it's fewer views or more views. But I think for the first time, we're actually able to deploy AV1 in the real world. I get super excited about it because 5 years ago, this was just kind of pie in the sky idea, and now it's happening at scale. And so, yes, the big streaming services are doing it, but really anyone who has popular content can do it. And so that's it. That's all I got. I think that's my next slide. Any questions?
Yes, we do. I'm going to start with my questions here because I have so many questions. I have a notepad and an article up. Okay. So practicality. I come from that now. I worked at Akamai for years, and I was in research and development. Loved it. It's great. I work at Paramount now, and we're all about distribution, production, and practicality. We're looking at HEVC. We looked at AV1. We looked at compute cost. We looked at those numbers right there. What's the scale of hits to make it worth it? Mm-hmm. Ultimately, everything's foiled with the devices on the end. That's my position. I work on the player side. You have Samsung devices from 2015, 2016, 2017, 2018. Now you start to be able to decode HEVC. AV1's not on these devices yet. Maybe they come out in 2023, but that takes till 2025 or 28 to get to the point where that's actually encodable in your entire library and deliverable to all endpoints. So how does that concern you about the rollout? I mean, obviously HEVC has been around for how many years now, and VP9, VP10, and all these codecs. Patents aside, what I'm really addressing is Jan Ozer just wrote an article about how HEVC has surpassed AV1 recently on actual device capabilities. We're seeing Chrome enabling it on desktops. We're seeing it in almost every smart TV or connected TV device. How do you think this is going to play out in reality? I'm all for open codecs, and do not like MPEG-LA patent pools, but how does this work out?
Well, I think it's a multi-codec world. We're already in a multi-codec world, right? Which codecs are you using in production? All of them. So, some more than others. Where's it going? In this direction, right? And this could change, and but you do see HEVC, AV1, and VVC at the top. Like we're working. We have a prototype implementation for VVC. We're definitely going to roll out VVC. Why? Because it's another tool in the tool set, and it's an appropriate tool for some use cases, and AVC is appropriate for some use cases, and HEVC is appropriate for some use cases. So I think it's, the way I see it playing out is it's going to be multi-codec. It's not going to get consolidated to, like, I don't think there's the next version of AVC and everyone's just going to encode everything in AVC. I think you're going to encode for your target devices based on the popularity of your content, based on the features that you want to deploy. And so these workflows get more complex because you have to deliver different formats that are compatible for different devices and content. But the tool set also is getting more capable. And so because of that, you have a lot more flexibility, and it's easier to deploy these complex workflows.
Right, right. And you come into the concept of encoding cost, delivery cost, storage costs, right? So as you have multiple codec strategy on your platform, you have storage costs increase. Yep. Does your calculator take into account that permutation of okay.
Yeah. I think with multi-codec, right, inherently you have to store multiple copies of the same content encoded using different methods. And we actually, I don't have the slide here, but one of our large SWAT customers did a study on the total cost of ownership, and yes, the storage costs increase, the encoding costs increase, but the CDN, the egress costs from cloud and the CDN distribution costs, again, for popular content, has the order of magnitude in the reduction of those costs is much higher. So it covers whatever increases
simple business
you have.
math, right? It's savings here, cost here, there. Okay, so was there a formula on when YouTube's most popular content made more sense to take more compute cost versus download cost? So like, is that number 10,000 hits?
So I don't know what the YouTube algorithm was. We have our formula published in our calculator on the website, so you can check it out, and you might want to make adjustments based on like what makes sense for you. Because we make some assumptions in there on what is your per gigabyte delivered rate on the CDN, for example, or your egress rate. I don't know what it was for YouTube, but I'm sure they have a similar formula they use. And they focus on 4K content so far.
Hey, thanks, Igor.
Oh, hey.
Dan alluded to it because there was a lot of turmoil with all of the patent troll on HEVC. So what is your perception of the patent situation with AV1? Are the content producers and distributors protected from any patent troll because of the Google umbrella on the AV1 domain, or what is your take on this patent situation for AV1?
Well, it's a royalty-free codec, so it's guaranteed not to come with royalties. It's developed by the Alliance for Open Media, so we don't expect there to be royalties associated with AV1. It's hard to say really what's happening with HEVC and how it's going to work with VVC. But presumably there's going to be some royalties and costs to use those codecs.
So you said in your calculator it's about 5 times more expensive to do AV1 compared to HEVC.
Yeah.
And it's whenever you have 10,000 views or more, it's the math works. You told me also that you can do live content. How comes that we haven't seen any Super Bowl or Olympics in AV1 yet?
It's a great question. I could see Super Bowl and Olympics in AV1 content, but yeah, I don't know. I don't know why that hasn't happened yet. Maybe Bitmovin encoder, live encoder supports it. I don't know how many other live encoders support it, but there's a cost, right? There's a encoding delay. So maybe for a big live sporting event, I would say there's the risk of broadcast delay, right? Increased broadcast delay, but also interoperability with devices still is a problem, right? So you have to have a really good way to choose the right codec for the right device, and you don't want to get that wrong. I certainly don't want to get that wrong for like a really big, important live sports event. That's my guess. I don't know. I don't know if that's the right answer.
I'll give a follow-up on that one.
Okay.
So you mentioned with VVC, there are certain use cases that make sense versus AV1. What are those use cases?
So I don't know yet for VVC. We have our prototype implementation of VVC. It's not generally available, so I think we haven't figured out what are the right use cases. But you know, it's supposed to. It is more efficient than HEVC. I would say it's competitive to AV1. I don't think the use cases are substantially different, but then you're still, I would say it's the next codec up in the queue. You still have to work through all of the device compatibility issues. So I think that's going to take some time.
So what's the end-to-end compression latency for encode to decode? Because the fact that the cost factor is so much higher would suggest that the latency is higher, right?
So actually, no. Well, it depends on the encoder you use, right? So if you do a distributed encode, like something like Mike was showing, right, where you have multiple instances, you know, maybe some of those are really small, maybe they're spot or preemptible instances, and you can distribute your encode across lots of instances, you're not really increasing your turnaround time, right? That you can scale that horizontally, and it works really well for long-form bot assets. Just, you know, speaking from how Bitmovin does it, we do split and stitch, right? That same approach. Take the asset, do an analysis, split it up across as many instances as you possibly can if you're optimizing for speed, and then, you know, they do their individual segment encodes, you put them back together. That happens very quickly. It's just more expensive because you're using so many more instances.
So you're saying it's relatively comparable to H.264,
yes.
Right? Okay.
Yeah, and our live encoder does AV1, and I don't know the broadcast delay, but it's very small.
Yeah, so I mean, as a follow-on to that then, so the question about like why haven't we seen it in Super Bowl or World Cup or anything like that, I mean, obviously, you know, you wouldn't just use that as your only format, but you'd probably, you know, simulcast it in multiple formats, right?
Correct. You would have to do it that way, but then you have to have really reliable logic client side to choose the right format for the compatible device.
Yes. Yeah, so it sounds like it's not really a latency driver. Why we haven't seen it with live. It just must be adoption, right?
I think
if there was enough demand for it, people would do it.
It's the end device.
Yes, exactly.
I mean, you say 40% coverage though, and then World Cup's like 20 million viewers or whatever. Like, that seems to pay off pretty quick.
I think it would, but I think if I was broadcasting one of those live events, and I'm not, but if I was, I would want to make sure it's bulletproof. And I don't think AV1, using that for a live broadcast at that scale, I don't think that's bulletproof yet.
Right, right. So our executives at our company we do have the Super Bowl next year, and I think it's Fox has it this year, NBC last year. CBS has the Super Bowl next year, and we probably shouldn't be talking about this on live video, but no, we are very much. We're gonna do H.264. That's all I can promise. We just got out of meetings today. We're talking about we really want to bring HDR, HEVC to the Super Bowl. We will. In 4K. So Paramount Plus hasn't quite figured out the paywall to get up to 4K subscriptions yet. So we'll figure that out, like YouTube TV has the second level. But I will bring that back. So really, here's my question. Why should I go to my executives tomorrow and tell them that we should do AV1 for the Super Bowl versus HEVC? Just kidding.
I would,
yeah. And I will. I'll push for it. I love open. I hate patents. So.
It's a fair question. I wouldn't push for the Super Bowl yet. I would maybe push for like your popular VOD assets.
Okay. So.
Basically, it's maturity.
Yeah.
It's not latency. It's not adoption. It's not really cost. It's really maturity.
I think so.
So you're saying if we have popular assets on a device that can handle AV1, and we have a system that can manifest, manipulate, and grind down device capabilities, that we should serve it because compute cost and overall efficiency is better.
I think you can save some money.
Okay, I'm going to do that tomorrow with my meeting.
Sweet. Do it.
But what do you think is the most dangerous thing for everyone in live? Do you fear the encoder to crash, or what's dangerous?
Dangerous. I don't know. I don't think the encoders are crashing. Yeah. I don't know. I don't think it's very dangerous, Nicola. I think it's pretty safe. What do you think is dangerous?
Portland.
Well, I mean, I don't think it's safer for. I think it's safer for less high-profile events. I don't know. I don't think Super Bowl is the event to experiment with AV1 yet. I think once there's more device adoption, once you have really reliable switching and choosing of codecs, and I think once you have an encoder that will always have a consistent broadcast delay, then sure, use it for live events. I think it's too early for live events. Personally, it's possible, but too early.
Potentially a very esoteric question. Are you guys tracking how generative AI models compare to codecs? And if in the future of, say, past VVC, that there could be encoders that are basically just doing AI-based compression, sending features down to the client, and the client is regenerating the video at ridiculously low bit rates, and if that compares and is potentially the future of codecs in general? Yes, it's a little esoteric.
So we are experimenting with neural nets for encoding, compression. It's a whole different world. I am not an expert on it by any stretch. Could it be the future? Sure. I think, we're seeing all kinds of interesting stuff happening with machine learning. in general, and I think that could definitely be applied to compression. There's there are methods and approaches that have been tried, but again, it's like, you know, it's like talking a totally different language. So
Thanks.
it's exciting,
Yeah.
and we're definitely experimenting, but I don't think there's anything sort of, you know, even prototype level to share at this point.
Thanks.
Just following up on that, NVIDIA actually has some research papers they've published on exactly what you described for video calling, and they can do HD equivalent video in kilobits a second, if I'm remembering reading the paper correctly. It hasn't scaled to all forms of video yet, but there are working prototypes out there of what you described. But my question was, in your comparisons between AV1 and AVC, is that AVC long GOP or AVCI?
Sorry, long GOP or?
AVCI, only iframes.
I don't know. It's a great question. I would think so, but I don't know.
Thank you.
I'll get back to you.
So at the beginning, you had talked about AVC being, or sorry, AV1 being difficult to encode but easy to decode. Does it need like a hardware-based decoder, or can you decode it in software on like a normal-ish CPU?
You can do software decode on a very fast CPU. Hardware decode is highly
Ideal.
It's ideal. Absolutely ideal.
Cool.
And there, like I said, you know, Realtek for the Roku streaming stick. Broadcom's got a chipset. I mean, the chipsets are there, and we're seeing more announcements of them.
Yeah,
I mean, just
that's
in the
where
last
like,
year.
adoption comes into play. Because I'm like, if you could do it software, then adoption becomes almost an easier problem to solve.
Yeah.
And then the second one, it's not really a question as far as like, you have the graph you have a lot of graphs, which is amazing to display visual information. But then you get to the 10,000 viewer slide.
Oh yeah.
I want to know what the curve looks like, because we talk about things, Super Bowl, World Cup, IPL, so on and so forth. I want to know what that curve looks like. You know, when you push that from 10,000, 10,000's cool.
That's a good
but
idea.
Like, what's a million? What's
Yeah.
5 million? So
That's
on
a
and
good
so
idea.
forth. Like, because I think that's where it's like, you know, somebody like Paramount or whatever, like that's what I want to know. You know, 10,000. Whatever. I'm not even going to touch 10,000 realistically. Like, we want to know big. Yeah, 10,000. We're not even going to look at 10,000. Like, don't waste my time. Like, we want to know big numbers, right?
Yeah.
Big numbers.
I mean, all we have to do is run the calculator. a bunch of
Yeah. So I
times.
think, if you could, like, you know, one
Okay.
curve, couple curves, whatever. Yeah, just right. Just
Sure.
do it live.
Everyone go to the
it'll be
calculator.
good. But I mean, because but you do call it good, like storage, but storage is basically nothing. Encoding, when you're looking at a lot of viewers, encoding is basically nothing. And then when you save on egress, like that could be huge, especially
Yeah.
when you get into like other parts of the world where egress costs can get considerably expensive, right?
Yep.
Like a lot of money goes into that. So I don't know, it's just, you know, something that I think, not a question again, but like something I think could add some value.
That's a good suggestion.
Just as a consumer of
Yeah,
this information.
we're gonna do it.
Cool.
We're
Thank
gonna
you.
run it a bunch of times and make a graph for you.
Awesome.
I'm gonna get your
Awesome.
info.
Yeah.
So I'll
We'll
send it to
trade.
you.
We'll trade.
Well, I mean, the developer report is really a survey, but yeah, definitely, I think it.
The state of the codex, I'm sorry, one of the many great PDFs.
Sounds good. It's a good plan.
So I have a question for a friend who's too embarrassed to ask it himself. But there's rumors that there's an AVC2 that's lower latency using quantum entanglement. Can you comment on that?
Sorry, in AVC2? I haven't heard of this.
Is there someone back? Yeah.
So what does the file type look like on this, right? What's the size? What's the file type?
So I didn't include the the sizes here, but I mean the output file is it's a WebM container. Yeah, it's a WebM container. It's small, so like if you have a
like a red file, it's split into a bunch of small files, or
so usually it's a distribution encoder, right? So you're creating an ABR stack, an adaptive bitrate ladder. So you usually have a handful of renditions at different bit rates. So like you might have a top bit rate of, I don't know, 1.5 megabits per second for an AV1 encode, like a 4K 60 frames per second AV1 encode. The top rendition would be maybe 1.5, 2 megabits, all the way down to 200 kilobits. And so you add those up. I don't know what the file size would be, but 30% smaller than HEVC and VP9.
some good savings, yeah.
Yeah, it's pretty
Thank you.
small. I mean, compared to an AVC encode, for example, if you want to generate, well, AVC is not a good example. Compared to an HEVC encode, if you want to generate a 4K 60 frames per second, most of the HEVC encodes will be anywhere in the 15 to 25 megabit range.
Yeah, I was just going to ask that. You said 1.5 megs
Yeah.
for an AV1 4K?
Yeah.
Okay,
Yeah,
that's the information I need.
Yeah, it's pretty. It's pretty.
We're looking at 15 megs per second for the 4K. Oh, what was that?
I don't know.
15 megs per second for that 4K same rendition in HEVC. So
Yeah.
that's really the remarkable number.
Yeah, and we have some samples that we run that we can share with you. Again, if you're interested, lots of details on just go to bitmovin.com/AV1 and you'll see a ton of stuff. Research we've done, test assets we've run, ABR ladders, and all that.
Awesome. Thank you so much. A round of applause for Igor Ozar. And with that, we're out of beer, we're out of pizza, and we're out of time, folks. So thank you for coming out. Really appreciate great attendance. Look for another one of these in the next 2 or 3 months, and we really appreciate you all coming back and taking the time for it. Thank you.